Hi there, welcome back to this channel. In today's video, we're going to be exploring the four fundamental forces. Now, these are the four forces of nature that control primarily all interactions that exist in nature, from the atomic scale down to, up to the astronomically large objects such as the planets, the stars, every object in the universe are pretty much under the control of one or more of these fundamental forces. And they include the gravitational force. I use the mnemonic GEOS to remember, GEOS. Okay, so where you're supposed to use J normally, use G for Geos. So you have maybe Geos, G for gravitational force, E for the electromagnetic force, EM force, and W for the weak nuclear force, and S for the strong nuclear force. All right. So let's start with the gravitational force. Now, the gravitational force, as you already know, and as described by Isaac Newton, is the force that pulls every object towards the center of the earth, that is in the earth, it pulls all object towards the center of the earth. And of course, overall, it is the force that actually pulls two masses to itself, to each other rather, pulls two masses to each other. So that shows you that it is always attractive. The gravitational force is always what? Attractive. And the magnitude of the force by which this attraction happens is given by the gravitational law, the Newton's gravitational law, which we know as the inverse square law, one of the inverse square laws that we have, which says that the force is directly proportional to the masses, to the product of the masses rather, and inversely proportional to the square of the distance between the two objects. Okay, now one thing you should also know is that the force is the weakest. This gravitational force is the weakest, but it has an infinite range. So if in case you do not know, it is actually what controls the structure of the universe. Yes, if you have seen Albert Einstein's analogy of the space, of how the space is. So it is such that the mass of the sun is pulling down on the fabric of the universe and every other, because of that mass, every other object in space, every other body in space is moving, the planets, in this case, we are talking about the planets, move around the sun, okay, and are pulled towards the center. Yes, and they are pulled towards that center that is formed by the sun. Okay, so my point is that it has an infinite range, okay? It pulls objects together. It's, and no matter how big the object is, even though it is the weakest force. And the equation already also tells you that the larger the distance, the lower the force. Exactly. A minute difference, or such as reduction, a minute reduction in the magnitude of the distance might lead to a great reduction in the distance. A little reduction in the distance might lead to a big difference in the force that will be felt. Exactly. But keep in mind, it is the weakest of all the four fundamental forces. Now, it is responsible for orbits of the planets and falling objects. I just told you now. That is why if I throw this marker up, it comes down because gravity acts on it. Exactly. Now, structure of the universe, like I said, and orbits of the planets. Now, then the carrier particle here is the graviton or graviton, even though that is hypothetical. Now the second force is the EM force, the electromagnetic force. Already you can see there are two words here, electro and magnet. Okay, so what does that tell you? That tells you that there is electricity and magnetism in discourse here. They are interacting here. Okay, so what produces electricity or the electric force? It's basically charges, isn't it? Now, in this case, when we are talking about just electricity, we will be talking about charges at rest. Charges at rest. Now, the charges have to move before magnetism can come to play. If the charge do not move, then they cannot exhibit a magnetic field. You know, we have studied that it is moving charges which creates current, or bring about current or charges, are what produce magnetic field. They have magnetic field around them. Okay. So that is electromagnetic force for you. So that's electric component and the magnetic component. And of course, for that reason, it is the force that actually is responsible for light. And we have discussed before that the light is formed when or basically EM waves altogether are formed when the electric and the magnetic field of the earth are acting at right angles to each other. So it acts between charged particles. And Coulomb's law explains the force, the magnitude of the force between charged particles, between two charges especially. And it is also another inverse square law. And according to him, the force is directly proportional to the product of the two charges, but inversely proportional to the square of the distance between them. Now, the difference between this and this is not just in the strength, because this is much stronger than this, but also that this guy can be both attractive and repulsive, while this one can only be attractive. Is that clear? This one can be attractive and repulsive depending on whether we have like charges or unlike charges. If we have like charges, we're going to have what? A repulsion. And if we have unlike charges, we're going to have what? An attraction. If the force will be attractive. So it is much stronger than the force of gravity. Yes, very, very much stronger than the force of gravity. Then it is also the force that, is that magnets, exhibit. I mean, that helps in the magnetism of things, the magnetization rather of things. Then we have chemical bonding. It is also the force, yes. Electrostatic force is what helps in the binding of things. For example, in the formation in chemistry, I've explained this before, where we have something like this and this attracted, they are attracted together, and what keeps them informed is the electromagnetic force. Then, of course, we have don't forget there are two forces in play here, like I said, the magnetic force and the electric force. Now, it also has infinite range, albeit still remember that as the range is increasing, the force is diminishing. As the range, the distance between the charges is increasing, the force, the magnitude of the force felt is reducing. Then the carrier particle here is photon, and this one has been proven. Is that clear? This one has been proven over time. So only this is hypothetical, but this has been proven. The carrier particle of this EM force is photons. Okay. All right, let's go to the strong nuclear forces. Now, the strong nuclear forces and the weak nuclear forces, both of these act in the atomic scale. Okay, so this one acts in the large scale, the astronomical scale. You understand that guy? Then the electromagnetic force, yeah, pretty much our everyday thing, everyday stuffs. From our clothes sticking to our bodies, from the doorknob, we touching the doorknob and getting shocked from rubbing something on something, and then the thing becomes attracted to something else. But the strong nuclear force is acting in the atomic scale. So the strong nuclear force is actually the strongest of all the four fundamental forces, and it is the problem is that it has a very short range. In fact, it acts at approximately 10 raised to power minus 15 meters. That is the range over which the strong nuclear force acts. So that is why it is acting only in the nucleus of the atom, nucleus of the atom, and it is what binds, it binds the protons and neutrons together. So you would have heard that in the using the planetary Bohr's planetary model of the atom. I'm going to be drawing the Bohr's planetary model. So you have this. So we have, these are orbits around the nucleus. So in this nucleus, we basically have the neutron and protons. Okay. Now the neutron and the protons are both together in the nucleus. Okay. So it is the strong nuclear force that helps to bind them together, that holds them together. Then and it also binds the quarks. The quarks, why I say quarks? The quarks, which forms the protons and the neutrons, yes. The protons and neutrons can also, their quarks are actually fundamental particles as well. So, and they are the ones that make up the protons and the neutrons. So in fact, the neutron can undergo decay by action of the weak nuclear force and become the proton and form proton, electron, and what is called antineutrino. The neutron can break down to form the proton, electron, and antineutrino. Okay, so basically I'm trying to say that the quarks help to form the protons and it binds them together. So now, how does it bind them? So the carriers of the strong nuclear forces are the gluons or gluons. So the gluons, think of them as glues basically. They are like glues that help to bind the quarks together. It is the gluons that help to bind the quarks together. And we also have, so the quarks can also exist in different forms. Not like exist in different forms actually, exist in different forms because of what we call color charges. Now this color can be misleading. You are thinking of them in terms of your rugby. They don't refer to your red, orange, yellow, whatever colors. They are actually just, now the color charges are just a way of referring to the particles that, the charged particles, they are analogous to our protons and electrons. Just like proton is positive, electron is negative. Color charges are actually, we call them quantum chromodynamics. So they help us to know the type of quark, is that okay, in quantum chromodynamics, is that correct? So colored charges. So when we assign colors to them, those colors are not actually colors such as green, white, and green, red, and all. So, and that tells you that if an atom can be neutral because of possession of equal number of proton and electron, when the number of colored charges too, the number of colored charges or the type of colored charges that a quark has, we also tell you its stability, whether it is stable or neutral, or understand. Okay, so just like they are analogous to protons and electrons, like I said. So that's the strong nuclear force, the strongest, and it helps to bind the quarks together, helps to keeps sanity in the nucleus. Does that make sense? Now let's go to weak nuclear forces, the weak nuclear force, actually. So it is responsible for radioactive decay. Yes, it is responsible for radioactive decay, especially beta decay. The beta decay that spontaneously goes on in the sun. So the overall radioactive reaction that is going on in the sun is, dependent or is brought about by the weak nuclear force. Okay, then it also acts at a short. It has a short range in its action, shorter range than even the strong force. You know, the strong force we said is approximately 10 raised to power minus this. This one is approximately 10 raised to power minus 18 meters. Is that clear? So you see that's very small, you know, very small. These two act at a very small scale. So that's why we said they are only concerned with the stability of the nucleus, okay? Now, it causes one type of quark to change into another, yes. Transformational changes that occur with the quark is driven by the weak nuclear force. So when the neutron also breaks down to give us proton, electron, and antineutrino, it is due to the weak nuclear force. And of course, the carriers, the particle carriers include the W and Z bosons. Now we have two types of Ws. We have the W positive, negative, and the W positive, W negative bosons, and we have the neutrino. Now both of them, these are just products of breakdown of decays, radioactive decays, exactly. So, and that's pretty much it. That's pretty much it. What have I not discussed? Yes, so those are the four fundamental forces, the G's, the gravitational force, the electromagnetic force, and the two that act, this one in the astronomical scale, this one in the everyday life, with common things. Of course, these also act on common things, exactly. The strong nuclear force at the atomic scale. Alright, if you did gain value from this video, do well to subscribe to the channel and click the bell notification. And also wait, I'm beginning a series on the electrostatics again, so do well to watch those videos as I post them. God bless you as you share and like and subscribe. Amen.